All right, welcome to section 3. Getting closer. So this one is talking about synthetic and long division. So long division, you learned about in 4th grade, 5th grade math, something like that. So if we had, I need a paper, Where's the paper? Oh, we'll use this paper. All right, so if we had like 21, 7, 4, 8 divided by 9, I hope that doesn't work. You would take this 9 and you would divide it into 21, 7, 48, right? So the first thing you would do is say, well, does 9 go into 2? It doesn't. How many times does 9 go into 21 then? Well, 9 goes into 21 2 times, so you would do 2 times 9 is 18, and you would subtract that number, right? So we'd have 21 minus 18 would be 3, and then we'd carry down the next term. So we'd say, how many times does 9 go into 37? Well, it goes in 4 times, and it's 36, and then you would subtract that. So we have 1, and then you carry down the 4. So then you'd say, how many times does 9 go into 14? Well, it goes in 1 time, so that would be 9. You'd subtract it, and 14 minus 9 would be 5. Then you pull down the 8, and you say, how many times does 9 go into 58? Well, it goes in 6 times. So you write 54, because 9 times 6, 54, and you subtract it, and then you'd have a 4. So at this point, you could write like remainder 4 or something like that, but now that we understand math, we are dividing that 4 by the 9 still. So what this really is 2, 4, 1, 6 with a remainder of 4 ninths. So this is the number that we are actually equaling to, that we are dividing by. Not dividing by, I'm sorry, that we are getting out. So it's, I think, called our quotient, if I'm correct. I'm pretty sure I am. But this is, so notice the remainder was put over what we were still dividing by. Right? So we're doing the same sort of deal, except now we're going to be doing it with polynomials. That's really our only difference. So really this is used to help factor and find solutions of polynomials. So it just makes our lives a lot easier, especially back in the olden days when mathematicians didn't have calculators. I know we do now, so we use them some. But when they didn't have calculators, they could find their solutions and then factor the polynomial factor our polynomial completely, which is what we're going to be doing in the next video. So you'll see somehow that works, but we need to understand the division before we can actually start using it. So this video is more about process. The next video is more about the use of it. All right, so what this is, I have x cubed plus 6x squared minus 5x plus 4 divided by x minus 4. So I'm going to set this up exactly like I set that other one. So I'll take the x minus 4, pen, right pen, I need your help, x minus 4, and I'm dividing x to the third plus 6x squared minus 5x plus 4. All right, so now what I'm going to do is I'm going to see how many times does x minus 4 go into my first term. Now, it's kind of confusing, but what I look at, I only look at the first things. So x and x to the third. How many more x's do I need to get to x to the third? Well, I need x squared. So now what I'm going to do is I am going to multiply that x squared by x minus 4, so x squared times x minus 4, right? Just like we did in the other division, and that's what's going to be going into that line right there that I subtract. So I have x squared times x would be x to the third. I'm going to write it in black, so I'm going to do something. So x to the third, and then x squared times negative 4 would be minus 4x squared. Right? So now remember, we subtracted that line. We have not done the minus yet. So now when we subtract this line, if I subtract x to the third, it's now negative x to the third. If I subtract the negative 4x squared, it's now plus 4x squared. So now that I've done that, I can actually bring everything down so that x cubed minus x cubed makes 0. Your first term should always go away every time you figure out what goes up top. Now I have 6x squared plus 4x squared, which gave me 10x squared. And last time, when we did our division, we only copied down like one thing, the very next thing. I actually continue to copy down all of my polynomial to make sure that I stay in order. So I'm going to copy down the negative 5x and the plus 4. So now we complete the process again. It's really just that process over and over and over. So I need to determine what goes up top. Well, in order to get 10x squared, I need to multiply x by 10x. I want to get exactly the same thing. So then when I divide, or I multiply to get down here, I take what I put up top times the x minus 4 to figure out what I'm subtracting on this line. So now I have 10x times x would be 10x squared. 10x times 4 is minus 40x. Then again, I need to subtract the line. So minus, negatives change to positives. Then I can actually subtract these things. Negative 10x squared plus 10x squared makes 0. So again, I get rid of my first term. Negative 5 and positive 40 make 35x, and I'll carry down my positive 4. Next thing I do, again, we're just repeating the process. So if I want to get x to be 35x, I need to multiply it by 35. So that when I do that, 35 times x minus 4, to get the next line, that will turn into 35x. And then 35 times negative 4 is negative 140. And again, last thing I'm going to do is change my signs, so minus and plus, so that I get down here and I have 144. So now with that 144, I'm kind of stuck because I can't multiply x by any polynomial or any monomial in order to get 144. It'd have to go like a 1 over x or something. So what we do at this point is that is actually our remainder. So I have a remainder of 144, and remember, we put our remainder over what we're dividing by, so I have plus, because it's positive, 144 over what I'm dividing by, which is x minus 4. This is the result of that polynomial division. So remember, what we can do with this is if I wanted to check my answer, which I don't really want to, if I multiplied all of this by that x minus 4, I would get back to my original polynomial that I did that I had before I divided anything out. So the thing in the pink is our answer. I'm just saying that if I multiplied it times x minus 4 again, I should get my original polynomial. That's it. This is polynomial division, or long division. So let's look at another. Still dividing by x minus 4. I'm just going to change it up a little bit. That's all right. So 5x squared minus 17x minus 12, and I'm going to divide out x minus 4. So in doing this, again, the very first thing, think about what you need to multiply x by to make it the same as 5x squared. Well, I need a 5 and I need an x. So when I multiply 5x times x minus 4, 5x times x is 5x squared. 5x times negative 4 is negative 20x. Then again, I need to subtract this line, so change my signs, such that I get now, that makes 0, so negative 17 and positive 20 makes 3x minus 12. Then to get 3x from x, I need to multiply it by 3, so that now 3 times x is 3x. 3 times negative 4 is negative 12. Huh, interesting. So now, check it out. When I subtract and I change my signs, I get a remainder of 0. So what that actually means is this is a perfect factor. It's the solution, but it's also a perfect factor. So if I took x minus 4 and I multiplied it by 5x plus 3, that should equal the 5x squared minus 17x minus 12. So essentially this was factoring, right? We divided it out, we factored it out, so that we could find the 0 of that and the 0 of that way easier. So if the remainder is ever 0, it's called a perfect factor. It's also a solution to our quadratic equation. Not necessarily a quadratic, or polynomial. Polynomial. All right, so now, this next one. And sorry, the answer again, it was what we actually got out of it. It was the 5x plus 3. Sorry, I wasn't trying to confuse y'all on that. All right, so notice, this one, I'm missing some terms. I don't have everything, right? Because standard form would be x to the third and then plus something x squared and then plus something x, and then the minus 9 could come in. And on the bottom, I'm also missing an x. So when we do our division, what I like to do, especially on the inside, is I like to keep track of my exponents. So I have x to the third, and then I'll say I have 0 x squareds right now, and then I have 0 x's, and I have a minus 9. Right, so that just, it's going to help me kind of line them up. You'll see how it works as I go through. On the outside, though, it doesn't really matter. It just matters on what I'm dividing. So I'll still just write x squared plus 1 on the outside. So again, we're going to do the same process. So I have, in order to get x to the third, I need to put an x up there. So that I multiplied this, x squared times x is x to the third, and then x times 1 is plus x. So notice, that's why I wrote my 0x, because I have a term that I can line up with it. If you don't write that, you're going to start mixing up things. You're going to start combining things that aren't like terms. So I would highly, highly, highly suggest anything that you are missing, put a 0 in its place. You'll see one in just a minute that we have to have a 0 in its place. It won't work. It's going to be a faster division though. It's really cool. I like it. I like it a lot. So change our signs. So that makes 0. I don't have any more of those, so I'm not going to worry about copying it down. So I'm just going to go to this term and say this is negative x minus 9. So now that's really all we could do. It's kind of lame, but that's it. That's all we could do. So because we have x squared here and we have just an x there, so I can't reduce that really anymore. So I have x, and then I'll say plus negative x minus 9 over x squared plus 1. Another way you can see this, Apex might, because they don't like you, they might factor out this negative up here. So if I factor out that negative, what they can do now is this becomes x minus x plus 9 over x squared plus 1. They're making that whole fraction negative such that they could distribute it back through both terms. This and this mean the exact same thing. So just be careful as you guys are going through Apex. All right, next thing we're going to talk about is something called synthetic division. I think you guys have done this in Algebra 1 before as well, but if you haven't, just check it out. It's really cool. So notice this looks exactly like example B that we did. 5x squared minus 17x minus 12 over x minus 4, and we got 5x plus 3 as our solution. Well, shouldn't we get the same thing, right? But I'm going to show you the new division, which is called synthetic division. All right, so synthetic just starts out like this. What it is it's kind of like an upside down division, and inside, just like with our long division, inside we put what we are dividing. So all I'm going to take, though, are my coefficients of what I'm dividing. So 5x squared, so I'm just going to put a 5, minus 17x, so negative 17, minus 12, so minus 12. Right? So just the coefficients. Now on the outside, it's a little bit tricky. I need to have the solution, or x equals what? Well, if I added the 4, then x would equal positive 4 on the outside. Now here's another thing. Synthetic will only work with linear divisors. Only when dividing linear. Only when dividing with a linear. So remember, only dividing with a linear just means only dividing with x to the first. So I can do synthetic here. I can do synthetic with e here. I cannot do it with f though, so we're going to have to practice long division again there because that's a quadratic. And I cannot do it with g because that's a quadratic. So we'll be able to see synthetic with 2 examples here. You'll catch on though, it's super easy. So now, what I'm going to do is every time we pull down that first term, so I'm just going to pull down the 5. There's a 5 there now. So now to get back inside, right, the next step is going to be to go to this spot. To get back inside, just like when we were getting back inside our division earlier, we were multiplying. So I'm going to multiply 5 times my number outside. 5 times 4 is 20. Then I'm going to take that down. Negative 17 and 20 combine to make positive 3. Then again, to get back inside, 4 times 3 is 12. Negative 12 and 12 combine to make 0. The last number is always the remainder, and I box it out to make sure that I see that it's the remainder. So what this is telling us, we started out with an x squared, and I'm dividing it by an x. So if I have x squared and I take out an x, what this does is it gives me a single x. So this is telling me the coefficient of my x term, which is 5x, and then it goes down in order. So 5x, and then this is my constant, so plus 3 with no remainder. That's my solution. That's it. I'm done. Right? Same thing that I got over there. We knew it was going to be 5x plus 3. So that's it. That's synthetic division. All right, moving on. Notice here, I am missing an x squared term. So when I do my coefficients of the inside part, I need to have, just like when we did long division, I need to have a 0 placeholder. So I have 3x cubes, 0x squareds, negative 9x's, and then I have 17. All right. Now on the outside, make sure it's x equals whatever. So if I set that equal to 0, I need to subtract the 2 to the other side, such that I put negative 2 on the outside. All right, so there it is set up. So again, very first step, always, always, always pull down that first number. So I just have a 3 down here now. So now to get back inside, 3 times negative 2 is negative 6. 0 and negative 6 combine to make negative 6. Negative 6 times 2, or negative 2, is positive 12. Negative 9 and positive 12 make positive 3. Negative 3 times negative 2 is negative 6. And then 17 and negative 6 make 11. The last number is always our remainder. So we actually have a remainder in this one. So we have, notice I started with x to the third in this one. So now what this is telling me is this is 3x squared. So I have 3x squared minus 6x plus 3. And then with my remainder, just like we did in the other one, I'm going to put it over what I'm still dividing by. So plus 11 over what I'm dividing by, which was x plus 2. There it is. All right, I'm going to do another one with synthetic, and then I'll practice long division again. I want to show you another one. So just get rid of that squared right there. That squared is no longer there, so we are dividing by x plus 3. So first thing I notice, I have 0x squareds, so I'll need to put in a 0 placeholder. So I have 4, negative 7, 0, 16, and 8. On the outside, remember to solve for your x equals, so it should be negative 3 on the outside. All right, so now first thing, always, always pull that down, and then 4 times negative 3 is negative 12. Negative 7 and negative 12 combine to make negative 19. Negative 19 times negative 3 is 57. 0 and 57 combine to make 57. 57 times negative 3 is, let's see, 150 plus 121, so negative 171. Combines to make 155 negative. And then negative 155 times 3, let's see, is 450 plus 15. So negative 465, but it's positive 465 because I have a negative times a negative. And then I'll have the 8 with that, so that makes 483 as my remainder. All right, super ugly numbers, but that's what it is. Sorry, I keep getting hair in my face. God, I don't know how you do it, girls. That's probably why some of you cut off your hair. I would too. Just really get off of me. I can't see anything. All right, so I started with 4x to the fourth. So that means this is one exponent lower since I divided by an x, so 4x to the third. And then I have minus 19x squared plus 57x minus 155, and then plus my remainder over what I'm still dividing by. That's it. That's synthetic division. All right, one more time with long division, and then we'll be done. So on the inside, I have 4x cubed plus 2x squared plus 0x plus 0. I'm going to write all those terms. Then I have x squared minus 9 on the outside. So x squared times 4x will give me 4x to the third. Then multiply this 4x by what we have on the outside. So 4x to the third. And then 4x times negative 9 would be minus 36x. So I'm glad I wrote those terms. Change my signs on this line. So that makes 0. So I'm left with 2x squared plus 36x plus 0. And then I will need to multiply x squared by 2 to get 2x squared. So I have 2x squared, and then 2 times negative 9 will be minus 18. And I just need to subtract those lines. So I have 36x plus 18 left as my remainder. So this will be 4x plus 2 plus 36x plus 18 divided by x squared minus 9. All right, hopefully this video was helpful. Sorry it was super long, but I was trying to be informative. As always, please let me know what questions you guys have, and I look forward to talking with y'all. All right, bye.